Hi there, so today's lesson is 7.6 surface area and volume of cylinders. The objective today then to be able to calculate the volume and surface area of a cylinder and to solve problems involving 2D shapes. So prior knowledge before we start then, you should already be able to find the area and circumference of a circle. So using the formula A equals pi r squared and C equals pi d. And you should be able to substitute into a formula. If you're not sure about area and circumference of a circle, please stop this video, go back and do the previous lessons. Things you'll need to complete the lesson then: your maths book or some paper to write on, a pen or a pencil to write with, your scientific calculator, making sure that it does have a pi button on it, a ruler and a pair of compasses for drawing any diagrams. Okay, so we'll start with the surface area of a cylinder then. To find the formula for the surface area, it's quite useful if we draw its net. Now, the net of a cylinder, we've got a circle here that represents the top of the cylinder, another one that represents the bottom, and if we unfold the curved area of the cylinder, we actually get a rectangle. So remember, it's a prism. So every time that we draw a net of a prism, we get two of the shaped end, and all other sides are always rectangles, so this still applies even to our cylinder. And we've got here the height of the cylinder. So the question is, how can we find the width of the curved face? Well, this curved face needs to wrap around the circle at each end when we put it back together. So it's the same as the circumference of the circle. And the circumference of a circle is pi times the diameter. So the length of the rectangle is the same as the circumference of a circle. So the area of the curved face is pi d, length, times the width, which we've called h. So our curved face is pi d h. We then have the area of the two circles. Remember, the area of a circle is pi r squared. And there are two circular faces, so we need two lots of pi r squared. So that's how we find the surface area of our cylinder. So altogether then, we have 2 pi r squared, so that's two lots of the circular face, plus pi times the diameter, the circumference, times the height, which gives us the rectangular face. So two circles plus the rectangle. Make sure you make a really clear note of that before you move on. So why might we need to be able to do this? Well, imagine you're the person making this baked bean can. You're first of all going to need to know how much metal you need to make the can, and you also need to know how big to make the label. So for our can, it's got a top and a bottom, and the label is going to go around the circumference. So the circumference pi d, we've got our height, so the label is going to be pi d times the height. That's the same for the metal bit of can underneath. And then if we want the metal parts, we need the curve and 2 times pi r squared. So for just the label, we need pi d times h. That's how much paper we'll require. For the metal, pi d h plus 2 lots of pi r squared. All right, so how do these normally look when we see them? So we have a question like this. A tin can has a radius of 4 centimetres and a height of 10 centimetres. What's the surface area? So we're going to put those numbers into our formula. So here's our formula. 2 times the area of a circle, one for the top and one for the bottom. We're assuming that it has a top and a bottom unless we're told otherwise with these questions. So when it says a tin can, we take it that there is a top and a bottom on our tin can. So 2 circles plus pi d, the circumference, times the height. Now all we've got to do is substitute in the numbers in the appropriate places. So we need to know the radius, which we know is 4. We need to know the diameter. Now if the radius is 4, the diameter must be 8. And we need to know the height, which is 10. So we know all the information required, so we can put it into our formula. Our first part then, 2 times pi times 4 squared, so that's the circles on the top and bottom, plus pi times 8 times 10, that's the bit around the outside. So if we work those out, our first bit comes to 32 pi, so 4 squared is 16, 16 times 2 is 32, so 32 pi. Our second part, 8 times 10 is 80, so we've got 80 pi. Now we're doing this in this way because you may be asked to leave it in terms of pi. If you're just asked for a decimal, you could type all of this into your calculator in one go, as long as you're really careful. If you're asked, however, for the answer in terms of pi, then we work out the numbers, but we don't work out the pi bit. So we can add these together now, 32 pi plus 80 pi. We can add them because they're like terms, is 112 pi. So that's our answer in terms of pi. If I want to now work that out as a decimal, I can do 112 times pi in my calculator, which is 351.8583. Remember, we do at least 4 decimal places before we do any rounding, and then we can round that so to 1 decimal place, 351.9, and our units centimeters squared. So for each of these questions, I'm going to find them in terms of pi and then find them as an answer. And the reason I do that is because if I find these parts as decimals first, I might have to write down really long decimal numbers. It's much easier to write it in terms of pi with nice numbers at the beginning and then just have the decimals as the very last step in my calculation. Make sure you've copied down that example then and you're happy with those steps before you move on. Okay, sorry about that. 1 second. Okay, so there we are, that's better. There are 3 questions there for you to have a go at then. So make sure you use the formula. Make sure you're careful about whether you have the diameter or the radius. Remember, you need both for the formula to work, but make sure you put the right one in the right place. Pause the video, have a go at those now. Okay, so for our first one then, we were given the diameter of 10, so that means the radius is 5, and we also know the height is 10. So we've got all the information we need. So our formula, 2 pi r squared plus pi dh. Substituting the values, so 2 times pi times 5 squared, remember the radius here, the diameter was 10, so the radius was 5, and pi times the diameter times the height. If we work those out, we get 50 pi plus 100 pi, which is 150 pi. That's our answer in terms of pi. And if we put that in our calculator, 471.2388, etc., rounded to 1 decimal place, 471.2 centimeters squared. For the second one, again, this time we're given the radius, so we also need the diameter. So the diameter will be 4 meters. So put in our values, so 2 times pi times the radius, which is 2 squared, plus pi times our diameter of 4 times our height of 5. And we get 8 pi plus 20 pi, which is 28 pi. As a decimal, 87.9645, etc., rounded to 1 decimal place, 88.0 meters squared. Again, don't forget, it did ask for 1 decimal place, so we have to have a value in the 1 decimal place position, even if it is a 0. Our last one then, again, we've been given the radius of 7, so we know the diameter is going to be 14, and we know the height is 12. So let's pop those in there. So 2 times pi times 7 squared plus pi times 14 times 12 gives us 98 pi plus 168 pi, which is 266 pi. As a decimal, 835.6636, etc., rounded 835.7 centimeters squared this time. Make sure you've marked your work and that you're happy with those before you move on. Okay, we're now going to have a look at some problem solving. So we've got a water tank in the form of a cylinder. It's 4 meters diameter and it's 4 meters high. Now it is open at the top, so that's really important that we recognize that there is no circle here. There will be one in the base, but this is open at the top. It's to be made from sheet steel and painted with 3 coats of paint, inside and outside. So we're going to paint the inside 3 times and the outside 3 times. You're asked to find the total area of steel needed, So we need to find out how much we need to make it, and the number of tins of paint. Okay, so let's have a go with this one. So again, with these problem solving, you can either pause the video and have a go yourself, or you can work through it with me. All right, so part A then, the total area of steel needed means I need to find the surface area. That means we've got to find one circle, because there's only one circle at the bottom, the top is open, and the curved face. So for our steel then, we've got pi r squared, so just one pi r squared, so one circle plus the circumference times the height, which is the rectangle part. So we're going to put in our values there then. We were told the diameter is 4, so the radius is 2. So pi times 2 squared for the circle, plus pi times a diameter of 4 times a height of 4 for the curved face. So if we work that out, 4 pi plus 16 pi is equal to 20 pi. So that's in terms of pi, how much steel is needed, which is, as a decimal, 62.8318, etc., or 62.8 meters squared to one decimal place. So that's how much steel we need. Now we're going to coat it 3 times on the inside and the outside. So if we work out how much we need for one coat of paint, so one coat inside and outside together, so the surface area to be painted is 2 times 20 pi, which is 40 pi. So I've gone back to using my value in terms of pi here, because if I use this value, I'm going to have to write down all the digits in my calculator to make sure it's accurate. So it's much more accurate to say, okay, well, the outside or the inside was 20 pi, so outside and inside is 2 lots of that, so that's 40 pi. So I'm going to paint 40 pi's worth as one coat. Now we wanted 3 coats of paint, so that's 3 times 40 pi, which is 120 pi. So you can see it's much easier to use these numbers in terms of pi than these really long decimals here. So if I need 120 pi, that's my area to be covered, and we can cover that with 28 meters squared per tin. So we divide that by 28 to give us the number of tins. We need 13.4639, etc. tins of paint. Now I can't buy bits of a tin of paint, so I would have to round up to make sure I've got enough. So we would need 14 tins of paint. Okay, well, I hope you managed to follow that through. There are different ways of doing this, so there is different orders that you could do this in. So don't worry if you did the calculations in a slightly different order, as long as you ended up with the same answer at the end. Okay, we're now going to move then on to the volume of a cylinder. So remember, the volume of a cylinder is a 3-dimensional space. So it's if you were to fill it up with something, how much space would it take up on the inside? Now the volume is the area of the circular base times the height. So again, this is the same for all the different prisms you've looked at before. So we find the area of the circle and times it by the height. So our volume is pi r squared, that's the area of our circle, times our height. So again, please make a note of this formula somewhere nice and clear before you move on. All right, so how is this used then? So we've got again a tin can. It has a diameter of 5 centimeters and a height of 6 centimeters. Calculate its volume. So our volume formula said we needed pi r squared times the height, so we need to find the radius. Radius is half the diameter, so our volume is pi times the radius of 2.5 squared, so that's the area of the circle, times 6, which is the height. So don't forget to check whether you have the right values for your formula or whether you need to find them before you start. Now we can just type that straight into our calculator, and it tells me that's 37.5 pi. Again, as a decimal, I get 117.8097, etc. If I round to one decimal place, 117.8 centimeters cubed this time. So don't forget we're talking about volume, and when we talk about volume, our units change to cubed. Okay, so your turn again then. So there are 3 there for you to do. Again, Be aware of the information you've been given and what's required for the formula. So start with the correct formula, substitute in the appropriate values, use your calculator to work out the answer, making sure you give the appropriate units at the end. Pause the video, have a go now. Okay then, so for our first one then, so we should have pi times 6 squared times 10, which is 360 pi, or 1130.9733, etc. Rounded to one decimal place would be 1131.0 meters cubed. Our second one, pi times 4 squared times 15 is 240 pi, which is 735.9822, etc. And again rounded 754.0 centimeters cubed. Finally, our last one, this time we were given the diameter. We need the radius for our formula, so we need half the diameter, so we need that to be a 5. So we're going to do pi times 5 squared times 12, which is 300 pi, or 942.4777, etc. Rounded gives us 942.5 centimeters cubed. Make sure you're happy with those before you move on. Okay, again, so a final problem solving question. So as before, you can either pause the video and have a go yourself first, or you can wait and work through it with me. This time we've been given a cylinder and it has a volume of 144 pi centimeters cubed. So we've been told the volume and we're told a height of 4 centimeters. We're asked to find the radius and then find the surface area to 3 significant figures. Okay then, so we're going to start off by trying to find the radius. They've told me the volume, and I know the formula for volume is that V equals pi r squared h. There we go. So we can substitute in the values we know. This time we know the volume, so we're going to put the volume under the word volume, and we know the height, so we can put that in. What we don't know is the r squared. So our volume is 144 pi. Is equal to pi times r squared, we don't know r, times the height of 4. Now if I multiply these together, that's the same as 4 pi r squared. So we want to get r squared, so we need to get rid of the 4 and the pi from this side of the equation. And to do that, remember we do the opposite, so they're multiplied by 4 pi. So we're going to divide both sides by 4 pi. So our side over here, 144 pi divided by 4 pi. And if I divide this side by 4 and by pi, I'm left with r squared. Now we can complete this calculation. 144 pi divided by 4 pi leaves us with 36 equals r squared. Now you notice the pi's have cancelled out. If I divide something by itself, I get 1. 144 divided by 4 is 36, so that would be 36 times 1, which is just 36. If you're not sure, you can type that into your calculator and you will get 36. Now remember that's r squared. We were asked to find the value of r, so we need to now get rid of the squared. So the inverse of squaring is square rooting. So we're going to square root both sides. The square root of 36 is 6. The square root of r squared is r, so the radius is equal to 6 centimeters. So that's the first part of the question. The radius equals 6. Okay, so now we were then asked to find the surface area of the cylinder to 3 significant figures. So surface area, we've got our 2 pi r squareds for the top and bottom, and pi d times h for the curved part. So we've got our formula. Again, we're going to put in our values. So we now know our radius is 6. That's great. If our radius is 6, our diameter here must be 12. And our height, we were told, was 4. So 2 circles, 2 times pi times the radius of 6 squared, plus pi times diameter times height for our curved surface. And we work those out. We get 72 pi plus 48 pi is 120 pi. We want it to 3 significant figures, so we are going to have to change it to a decimal. We get 376.9911 to 4 places. Remember, we'll write down at least 4 decimal places before we do any rounding. 3 significant figures, the first 3 digits. So 1, 2, 3. So our 9 after our 6 makes our 6 into a 7, and we get 377 centimetres squared. Okay, so remember this is area, so we're back to centimetres squared. Okay, well hopefully you were happy with that then. You've worked through that today. That's the last of this series of lessons for the moment. If you need to, please remember you can play all of this series again.